Okay, so what you're now looking at is my desktop. I have mounted my camera onto the swivel arm of my desk lamp, and because the camera is so small, I should be able to give you a nice bird's eye view of anything that I'm working on a breadboard. We'll see actually how that works right now. Yeah, that looks pretty good. People should be able to get a decent view of what I'm doing. Might want to zoom it in a little. So now what we're going to do is we're going to take a look at the components that I ordered from Mouser. And right here, we have a box and a fancy knife. Sha-sha! Okay. So, yeah, I'm not sure if you can see that. Let me move the box. Okay, so what we have, typical kind of stuff from Mouser right here. A lot of components, bubble wrap, and a bill of materials. Okay, and might as well just start going over these one by one. I already know what's in here, I ordered it, but... Okay, so, first thing that we have here, this bag contains moisture-sensitive devices. Bag seal date. Okay. This is 1/2 watt, 10 kilo ohm, 5% resistor, I'm thinking. Yeah, carbon composite resistors. Okay. And it looks like they have these sealed up very nice and tight. I'll have to get into those and look at them more. And then, let's see, here we have a 50K potentiometer. And these are fun. See, and I got a number of them actually, because they're nice to have around. There we go. We'll get a nice look at those. So yeah, those will be nice because those will eventually end up being dials in my project, so I can dial things in. It looks like they're all nicely individually wrapped. Let me see. Yeah, they are. Perforated packaging, so I can tear them apart, and then they're all individually sealed. I'm going to go ahead and put them away, though. I'd like to try and keep things in the original packaging, just to, so I don't have to relabel things. Okay. And what do we have here? 1 ohm, 50 watt resistor. Now this I'm interested in. This is going to be a rather sizable resistor, even though it's only got a 1 ohm rating on it. And what this is going to be used for is my dummy load. Essentially what I want to have is I want to have a resistor with a low value, but a high heat dissipation rating. Or essentially an ability to get rid of a lot of heat very quickly. And so that's where the 50 watt comes in. Most of your teeny tiny resistors, like this one here, that could have a resistance of 50,000 K, or not 50,000 K, but 50 K. And the reason it's so small is it only has a 1/4 watt rating. So it can't really take a whole lot of heat, can't dissipate a lot of heat before you start to damage it. Whereas this larger 1 watt resistor, even though it's less resistance, it has that higher heat rating. And okay, my food is here, so I'm going to go ahead and get that, and I'll be right back. Oh, okay, well, I did not stop the camera. You just ended up sitting there for a couple of minutes. Well, back to the resistor. So yeah, this is a 1 ohm 50 watt resistor, and I got a couple of them, and as we can see, they're pretty big. I mean, this thing it's the size of my thumb. And it's encased in metal with a couple of mounting points so that way you can hook it up to a heat sink or some other form of heat dissipation. Because even though this is a big hefty 50 watt resistor that's supposed to be able to handle so much abuse, well, the heat, you still have to get the heat off of it. So you're still going to need to either have a heat sink or some air movement to make sure that you actually don't burn it out. Shouldn't be too much of an issue, however. For what I'm wanting to do, I'm only hoping to push a couple of amps across it, so it should be able to survive that. And then here we have, something nice and long. This I'm looking forward to. Let's see, yes, this is what I'm thinking it is. This is LM741 op amps. And I opted to go with the smaller version. And I'm not sure if you can see in the packaging, but what we have here is we have 8-pin dip packages, all nicely lined up in a piece of plastic. And I decided to go with single op amps per chip for the sake of simplicity, basically for my own thinking. And then let's see, what do we have here? TO220. This is also another important component. Let me try and remember off the top of my head what this is. I believe these are going to be transistors. No, actually no, even better. Speaking of heat sinks, these are my heat sinks. I'm going with small heat sinks. I'm planning on using a fan, so I'm hoping that I'll have enough air circulation where I don't have to rely on passive cooling. This is a heat sink for a 220 package, and you'll see more of what's going on with that later when I get into it. So we'll go ahead and roll these back up for now. And you may notice that, I have a number of similar parts. When I pulled out those op amps, I had a big long line of them. They only have 8 pins. Well, the reason for that is whenever you order components, order in multiples. If you're going to go pay for all the shipping, you might as well go ahead and, make the shipping worth your while. Now, what do I have here? I have a 10K potentiometer. So let's, yep, small little 10K potentiometers. These are going to, be handy for, little dials as well. Let's see, I was hoping they would be, all my potentiometers would be uniform, but, that's life. Sometimes it doesn't happen. Here's another thing. Now I'm starting to get dangerous. 1,000 microfarad, 35 volt electrolytic capacitors, polarized. So yeah, those will hold a lot of juice. I'm going to have to make sure I'm careful about what I'm doing with these, and I'm treating them respectfully and treating them right. These are not necessarily going to come in with the dummy load. I had to order from a few different places. I ordered from Mouser, I ordered from Adafruit. I got some things coming in from AliExpress. So yeah, it's, don't have everything that I'm wanting right now, and I kind of have a bit of a mixed bag. Let's see here. 5K potentiometers. Now this I'm happy about. I have a 50K and a 5K potentiometer in the same package. That's going to do a very nice job of helping me make controls once I decide to put everything into a project box. And hopefully I'll be able to get some kind of knobs that I can put on these. And if not, well, oh well. Still I have some dials. Let's see, what else do we have here? A PNP audio amplifier. Okay, so these are transistors. Now, this has caused a little bit of controversy with the folks that I have been kind enough to critique my schematic on the EV blog forum. They're telling me that I'm using PNPs and I should be using NPNs, and I'm getting all sorts of heartache over that. Well, the breadboard's going to decide. We're going to, try my schematic on the breadboard, see if it works. If it does, hey, that's great, wonderful. I was thinking properly about my design. And if not, well, then I've learned something and I have some spare PNP transistors. And what do we have here? Fairchild rectifiers. Okay, yeah, rectifier diodes. Yeah, these are going to come in handy for the constant current, or for the dummy load. And then, let's see, 1/4 watt, 10.5 kilo ohm resistors, 10.5K. Small little things right there. I ended up getting 1% resistors there. I wanted to make sure these were actually as close to 10.5K as possible. And let's see, I have 2 kilo ohm resistors here, 1/4 watt. These are at 5%. And this one, single toggle SPDT, single pole dual throw. These are on-off switches, or what are going to end up being used as on-off switches for my project. And let's see, another one that's exciting. 60 volt single N-channel Fairchild MOSFET. That's going to be an important part of my dummy load circuit, and I actually ordered 4 of them. I have a couple to burn out and a couple to make other things with. And let's see here, and the last component here in that box, we'll take a look at this. We have 35 volt 1 microfarad capacitors. Small little capacitors there. 1 microfarad's a pretty small value. Now, in addition to this, what I've just shown you, I also have already received a few components from Adafruit, and here we go, here are these. First thing I have is I have a temperature meter, and this has a couple of wires to take a power supply, and then I'm not sure if you can see it on the camera, but you also have a thermistor on there, and that'll do a nice job of outputting the temperature. I've already tested that, it works nicely. I also have a 10 amp panel meter. This is in a package that's similar to the temperature meter. It has different wiring. This has 4 wires coming off of it, 2 to power it and then 2 for your measurement. And then last but not least, I have a voltmeter. And once again, it's in the same package, the same form factor as the others, so that'll do a nice job for making my design, my final project come out looking rather nice. Now, we may want to know, why am I talking about building a dummy load? Well, it's because of things like these, right here. And let's take another look at this. And last but not least, take a look at this. Alright, and let's see here. I have a 4th little converter here that's still in the package. I'm not going to take this out of the package right now. But what these are power converters and regulators. This one and this one, these are both buck converters. This one can support up to about a amp and a half of current. It has a nice little built-in voltmeter and little buttons on there. You can get the voltage coming off the input or the output, or you can just turn the little voltmeter on and off. And then it has a potentiometer on it that's used to adjust the output voltage. And it can go up to a maximum of 1.5 amps. This is also a buck converter, and it operates in much the same way, except it does not have a nice little voltmeter on there to gauge your outputs and your inputs. It does have the potentiometer on this, and this one's made from a company called Drock. They're becoming rather successful for making little power converters like this. Not necessarily the cleanest on the soldering. They have a tendency not to clean off the solder flux. However, they do make very nice and functional little buck converters right there. And then, of course, what we have here, this is a 5-volt regulator on a circuit board that I ordered. And then this is another little regulator, I believe, that we can go into later possibly. And what I'm doing with the load, the dummy load, is I'm wanting to be able to design my own little power converter. However, in order to design your own power converter, you have to test it. And in order to test it, you have to put it under a load. So let's say I want to know how many amps this power converter can output. There are 2 ways that I can test this. Well, actually 3 ways. The first way is to go just check the data sheet. Check the specifications. That's not always the best, the most accurate information. The other way to test it is to get one of those big 1 ohm resistors and then start, just pumping juice across the 1 ohm resistor and measure my voltage. Remember, if we remember Ohm's law, then we can easily calculate the amperage or the current across the resistor if we know the voltage and we know the resistance that the resistor can offer. So if we have a 1 ohm resistor and we're sending 1 volt across it, we know we have a 1 amp current going across that resistor. Well, if you test things with the resistors like that, that's nice. The problem is you can only go up so high. If you have that little 1 ohm resistor, and you're only going to be able to have that 1 ohm resistor. You're not really going to be able to vary it much. I could adjust the output voltage on the buck converter, but if I'm really wanting to crank it up and see what the limits are, I'm going to need to have something a little better. So that's why I'm wanting to construct a dummy load where I can adjust the amperage that will go across the resistor. And the way that you adjust the amperage is essentially you adjust the voltage. You get one of those MOSFETs, you have your current coming in, it goes through the MOSFET, and then you adjust how much current the MOSFET will allow to pass through. That goes across that 1 ohm resistor, and then you can calculate your amperage. And so what I'm planning on doing is putting it all into a nice box and having little dials and panel and meters that I can use to get nice little bits of information. So that's what I'm gonna wrap up that video, this one, and for the next one I'm going to have my breadboard and I'm going to start prototyping some stuff. So until then.